Good evening, everyone. This is Lucidio Kuhn from the Technical MBA program at University of Washington, Bothell. And tonight we will be talking about Sophomore Jinx, specifically when applied to baseball. And then let's see if we can find an example of Sophomore Jinx when applied to the corporate world. We have a pretty busy agenda today. First, we'll talk about the problem itself. Then let's see what question will be answered with this presentation, the data that we're using for the presentation, how we grab this data and what we did with the data, the limitations and assumptions. We decided to do separate analysis and conclusions for pitchers and non-pitchers. We're going to briefly talk about what about other players, because we're going to be focusing here on players that earned the Rookie Award of the Year, and let's see if the Sophomore Jinx also apply to other players that did not earn that award. Then we'll be briefly talking about an example of the jinx in the corporate world and a list of references. So what is the sophomore jinx? Sophomore jinx is an alleged decline in athlete performance in their second season of competition. It is part of American culture. Many people believe that this is actually a fact. And many people think that the same concept of a sophomore jinx could be applied to other areas such as finance or corporate world. Okay, so what are we going to answer in this presentation? We will look at Major League Rookie Awards since 1949 and see if with that data we can refute sophomore jinx. The Baseball Writers Association of America gives the Major League Rookie Award to the first year player with the best performance. Then we are going to compare the first season's performance with the second season performance and see if such decline actually happened, if it actually happened, if it's significant enough for us to say that yes, sophomore jinx actually happens. So the data we got is composed of 3 tables with performance data for non-pitchers and pitchers from National and American League Rookie Award. In order to simplify, we combined the American and National League data for pitchers and then another for non-pitchers. That's because pitchers and non-pitchers have completely different performance metrics. So we're going to analyze pitchers and non-pitchers separately. This is our pitcher data. We have combined National League and American League in the same table so that we have a larger data set. Here we have rookie year, and here we have sophomore year with the results. And in special, we're going to be focusing on the delta, on the difference between rookie year and sophomore year. And in special, out of the special, we're going to be looking at the averages and standard deviation for the difference here. We're using the earned run average here because from out of the columns that we have here, it seems to be the best metric for performance for a pitcher. Let's zoom in a little bit in the picture data, specifically for the earned run average, the comparison between rookies versus sophomores, we can see that for rookies, the data is skewed to the left, and earned run average, the smaller the value, the best the performance. So what we're going to see pretty soon is if this skewing to the left, if the skewing to lower numbers, if it's big enough to be statistically significant. Here we will zoom in the picture data, especially the earned run average for rookie and sophomore. Rookies are in yellow, sophomore are in green, and we can see that for rookies, for the first year, data is skewed to the left, meaning lower numbers. And for earned run averages, it's important to remember that the lower the number, the better the performance. For non-pitchers, we also combine data from the American League and the National League. The data set is much bigger, as we can see, but again, we are combining both and we are focusing on the averages and standard deviations. In this case, our main metric, our only metric that we're going to be looking at is slugging average. For the earned run average and the slugging average, we based our decision on the sabermetric manifesto from Lahman, and we can see later in the references at the end where we found that. If we zoom into non-pitcher data, we see that rookies, again in yellow, and sophomore in green, they also have a difference. In this case, rookies data is skewed to the right. Slugging average, the bigger the number, the better the performance. So in this case, it seems that the rookies have better performance than sophomores. Let's see if this difference is statistically sufficient for us to confirm or refute the sophomore jinx. About limitations for this study. First, we only have data for baseball players that receive the Rookie Award of the Year. We are disconsidering all other players. Another issue is we only have data for 2 years. Even though the Sophomore Jinx talks about only first year being good and then second year having a decline on performance, having data only for 2 years, we cannot see if it's just a decline or if it's just a slump. Like a decline would be, I have here first year and then the second year goes like this. A slump, we have first year going like this, second down, and then maybe we can go back up with the performance. This is something that we cannot conclude. Another limitation is the author of this presentation, me. I am not familiar with baseball or the concept of sophomore jinx, but maybe this might make a better presentation here, because I will take a look at this with complete dispassionate disposition, and maybe we can get better conclusions. Assumptions for these studies are that the players that received the Rookie Award of the Year are actually good subjects for this study, that 2 years of data for 2 seasons are good enough to conclude whether Sophomore Jinx is plausible or not, and that our metrics that we're using for pitchers and non-pitchers, the earned run average and the slugging average are the best one for us to judge if a pitcher and a non-pitcher have good performance or not. Let's start our analysis of pitchers' data, where we will be comparing earned run averages. It's important to remember that the lower the ERA, the better the performance. We can see here that in rookies season we have lower ERAs as compared with the sophomore season. Not only that, but we can see that for sophomore season the distribution is much flatter because we have a much bigger standard deviation and when compared with the rookies. Let's analyze the hypothesis that pitchers' performance during sophomore season is lower than during rookie season. Our null hypothesis, coming back here, our null hypothesis is that the difference between rookie and sophomore season is less than 0. This means we are assuming rookies' ERAs are lower than sophomores. Let's not forget that the lower the ERA, the better the performance. We will be using pair tests for this with the following data. Alpha 0.01, the sample data size was 34. So our degrees of freedom was 33. We calculated the means for all differences between rookies and sophomores. It was minus 0.71. Our hypothesized difference was 0. Then we used Excel to find out what's our critical T, the T crit here, using alpha 0.01 and degrees of freedom 33. We got to plus or minus 2.44. We got the standard deviation for the table. The value was 0.94. That's the standard deviation between the differences between rookies and sophomores. The test that we will be doing is whether the observed T is bigger than the critical T. In this case, we would reject our null hypothesis there. We will not need to gather any data because we receive that with the table that we received to start this study. With that, we can start calculating using the paired t-test formula. We plug in the values that we found in step 3, and our t observed is minus 4.40. Now, minus 4.40 happens to be less than our t critical, that's minus 2.44. So our t observed is less than t critical, which is in contradiction with the test that we have here. In this case, we will fail to reject our null hypothesis. And as a conclusion, for pitchers with the analyzed data, sophomore jinx is plausible. Going back to non-pitchers data, we see that the slugging average for sophomore season is lower than for rookie season. That's because slugging average, the bigger the number, the best the performance. And again, just like with pitchers, sophomore season has a flatter curve, not so much, not as compared with the pitchers, but still it's flatter and the average is lower. Now let's analyze the hypothesis that non-pitchers' performance during sophomore season is lower than during rookie season. So our null hypothesis is that the difference rookie and sophomore is more than 0. Meaning we are assuming rookies' slugging average are higher than sophomores. That's because slugging average is directly proportional to performance, meaning the higher the slugging average, the better the performance. Just like for pitchers, we will use standard the paired t-test with same alpha of 0.01. Now the sample size is much bigger, 92. The degrees of freedom is 91, that's the sample size minus 1. The mean of all differences is 33.8. Our hypothesized difference is 0. And for us to calculate the critical t, we used alpha 0.01 and the degrees of freedom equal 91. We got 2.37 plus or minus. The standard deviation for the differences was 65.8. The test that we will execute is we will check if the observed t, the t obs, is less or equal than the t critical. In that case, if it's less or equal, t obs is less than or equal than t critical, we will reject the null hypothesis. Again, we will not need to gather data because we receive the data with the table. And so we can use now the paired t-test formula. If we plug the values here, we get an observed t of 4.93. What happens is that 493 is bigger than 237, meaning that the t observed is bigger than a t critical. In this case, we are failing to reject the null hypothesis. And again, the conclusion is that for non-pitchers, with the analyzed data, again, sophomore jinx is plausible. Now, I decided to take a look at how about what happens with all other players. In this case, I am comparing Rookie of the Year performance with all other players, the ERA performance. And we can see that, again, let's repeat that for rookies, we have a better performance in the season 1 than in season 2. For all other players, however, we have better performance in season 2 than in season 1. Here we can see for the first year, Rookie of the Year, and then on the second year, we have a higher value. Well, for everybody else, it starts with a much higher value than for the Rookie of the Year. But then in the second year, we have a slightly lower value. So if we would test for everybody else, we would be able to refute the sophomore jinx. But here we were focusing on the Rookie of the Year. An example in the corporate world of sophomore jinx could be companies after IPO. Survival rate for these companies go between 6 and 42%. But even the ones that manage to survive, most are underwater after the second year. And this is the end of my presentation. Hope you enjoyed. This is the list of references that I used for this presentation. Thanks for your attention. Bye.